You guys look very tired, and I feel like this is a great way to introduce student teachers. Table 11. You guys are going to teach this to the class. You can do it together. Okay, so as you head up there, which is a very long pause. Okay, it says air is being pumped into a balloon, it's a spherical balloon. I think we all know they're not actually spheres, but we're just going to pretend. At a rate of 800 cubic centimeters per minute, how fast is the radius of the balloon changing? At the instant the radius is 30 centimeters. 30 centimeters, that's a big balloon, correct?
Yeah, that's about 12 inch.
Yeah, that's a 12-inch radius even. That's a big balloon. Okay, so first thing we should do though is figure out what we are trying to find. So underlined what we're trying to find. Nope. Yes. Okay, erase the other one. Nice. All right, now when it says how fast is the radius of the balloon changing? Well, in calc notation, what is that? Because the word how fast means a rate, or even the word changing over there at the right. That should trigger to you that that's derivative. So it is telling us to find the derivative of what?
Radius.
Okay, so how do we write that? And so as teachers, you guys are welcome to call on anybody too. Like you don't have to like just explain everything. It's like me. I'm taking the day off. I'm making you guys the teacher.
Oh, that's good.
I'm still getting paid today, but I'm taking the day off.
Marvel, you have any ideas?
See, now you got the hang of it.
Um,
How would we write that as calc notation?
the derivative
The radius.
of the radius is 30 centimeters.
True, not the question that was being asked. How do we write the derivative of the radius in calc notation? How are all of our derivatives written? D something, D,
Yeah.
whatever,
So
yep.
would it be ddr because we're deriving
Close.
with?
I mean, you meant it correct, you just said it wrong, I believe. dr,
dr or dt.
correct. Good, very good. dr dt is what we're actually trying to find. dr dt equals question mark. Or we can just leave it blank to find the answer later. Did you write a question mark from the bottom to the top?
Oh, I know what I did.
Oh, you, yeah.
yeah.
I don't think I've ever seen that.
And then do we just derive volume?
This probably
of
might
the
take us an hour.
of a sphere.
Oh, wait, what are we doing?
Are we gonna derive the volume of a sphere formula?
Perfect. How did you come up with that though?
Because it's a balloon, so it's a sphere.
True, but how do we know it's not surface area?
Because it's cubic.
Good.
centimeters.
It mentions 800 cubic centimeters per minute, which is another derivative. But the fact that it says cubic centimeters definitely means volume. It doesn't use the word volume anywhere in the problem. I know for some of you that's usually just like a horrible thing, right? Like some of you need kind of the direct wording to be told what to do. And so a lot of these aren't going to have that. And so we have to look for the little clues. So good, let's write down the formula for volume of a sphere.
Over here.
Whoa, I don't know what happened there. I don't know what it's doing. You remember that off the top of your head? Nice job. Oh, see, I was so proud of you. But you did use a good resource. Volume of spheres on that page that we did yesterday. So if you need to look up some formulas, they're on that page. Or else Google it. Okay, so 4/3 pi r cubed. Is that a cubed?
Yeah. And And then do we just derive this with respect to time?
So here's a great tip as a teacher. If you don't know how to do something, you pretend you do, you turn to your class, you're like, how do I do this?
Maybe you guys
How
will
do I
say.
do this?
See? You play it off like it was your idea all along.
Can I roll? Oh, you.
Yeah, you definitely
You
can.
can roll, you can roll.
You can definitely roll. You're in charge. Well, I guess you have to decide if that's a 9 or a 6. It's up to you.
I think it's a 9.
Okay.
I have no idea.
Oh dear. But they didn't actually even ask you a question. Oh, yeah, you did ask a question, just how do I do this? That was pretty vague, but that's okay. I think you guys all know that we need to take the derivative though, right? I mean, that's every single one of our problems. So just do that. Even if you're not sure why, yeah, just do that because you know you have to. Like, let's use logic. If this was a test and you were totally lost, there's a pretty good chance that taking the derivative is part of the problem. So just do that. All right, so we need to take the derivative of that.
With respect to what though?
Oh. Well, so that other one that says 800 cubic centimeters per minute,
Oh,
the per minute definitely tells us it's with respect to time.
okay.
Yep.
And then just, yeah.
I'm actually pretty positive every one of our word problems is going to be with time. Doesn't have to be, but I'm pretty sure they are. Yeah, sometimes the whiteboard just stops writing.
And then we have to solve for the derivative of radius over the derivative of t, so,
You don't need to rearrange it right now if you don't want.
no, okay.
You can rearrange the formula at any point. Some people find it easier to do it at the end of the problem once like numbers are simplified and put together.
Okay.
You could solve for it now if you wanted to, but you don't need to. So I guess the main thing is once we have a formula, we need to fill in all the information we know.
Oh, so then this equals this, so.
Wait, how do you know that one's dVdt?
Because it's volume per time.
Good, very good.
Oh, 800.
The labeling is going to be your key to filling things out.
R times 3, and then we're taking it at 30 centimeters
Apparently a large answer here, okay.
times, we don't know this yet.
Good way to explain it.
Oh, this is the instant rate of change of radius at whatever time we're at.
Yep, that's perfect. That's what we're looking for. So let's see, we've got 4/3 times 3, which is 4.
Mhm.
4 times 900 would be 3,600. So we've got 3,600 pi, pretty sure. Did anybody else already do it? Okay. My brain doesn't always work right. It's got the right intentions, but it doesn't always work right. So 800 divided by 3,600 pi. Okay, as teachers, let's ask somebody why I would mark that wrong on a test.
It's not simplified.
2 reasons. Simplified is definitely one of them.
And you don't know where it's, because I just went right to left.
Oh, that's true. Your notation was bad. I actually could follow that, but your notation was bad. Neela, it looked like you kind of knew.
Oh, wait. never
Oh,
mind.
okay. You were going to say it was the way you wrote it?
Yeah.
Oh, I mean, sort of true, but I wasn't going to be that picky for this because standing in front of the room trying to do stuff is actually a lot harder than when you're sitting down doing it on your own.
Do you need to label it?
Good, yeah. Word problems, that's usually pretty key. So we would have to label stuff. So cancel out the zeros, 8 over 36, 4 over 18, 2 over 9. So 2 over 9 pi.
Okay. Centimeters per minute?
Yeah. You are right, Walter. As a whole, that is pretty sloppy, but
Yeah.
we'll not hold that against you because you guys did a very good job standing at the board. I actually didn't think you were gonna stay there the whole time. You guys did a great job. Nice job.
Oh,
Go ahead.
where you put the pie. Oh, actually, never mind.
So some of these questions, they will want the answer as a decimal. Some they don't specify. This one doesn't specify, so traditionally an exact answer is best.
Do you keep it on the bottom?
Yep. Well, yeah, because we divided by it. It doesn't have to like make sense in your head. It's just the answer. Go ahead.
Does it make a difference if you like write it as 4/3 pi or 4/3 times? Like how
As difference between what?
like do you see how he did 4/3 times pi? Could I have just written
4 pi over 3? Oh, go ahead. What were you gonna?
Yeah, basically.
Yeah.
Is that okay?
Yep, you absolutely can write 4/3 pi r squared cubed differently. They're all equal. The derivative would work out the same. The downside is if you write it as 4 pi r cubed over 3, you'd probably do the quotient rule or something. So it would feel harder, but it would be equal. Anything else somebody wants me to go over, cover on this one? Okay? This one was semi-straightforward, except for you're just not used to where to put things and what things stand for. Okay, next step harder. Should we roll to see who's going to teach? No? But some people have already gone, so they won't have to go. If you've already been called on or answered, you're done. 3. Well, that's actually kind of cruel. I feel like we should go for a table of at least 2 people. Or should I just like group your guys' table? No? Oh, geez. That was pretty adamant. 1, table 1. We've got a new problem. So this one's about a ladder sliding down a wall. It's actually a really popular problem because a lot of people can envision it in their mind. And you can't envision a ladder sliding down a wall? You have never stood on top of a ladder that slid down. It's not fun. I can absolutely picture it in my mind. You don't have friends that think it's funny to stop holding the ladder as you're standing there. Yeah, I definitely had friends that thought that was funny. There's no question why I'm afraid of heights now. But I guess step 1 for this one is we should probably semi-draw it. Like make a rough drawing of what this shows. So that's what I was hoping you guys could do. We don't even need to start teaching the problem yet. Let's just try to figure out what it says. It's hard to draw it from back there. I mean, I guess theoretically you could have drawn it together first on paper and then, yeah, that would have been fine. We'll just put you under high pressure instead.
Great.
That's okay. They feel the same pressure and they're sitting in their seats. Wow, you took up the entire board with that one. We can make it smaller as we can shrink it afterwards if you want.
The wall.
That's the wall.
Yeah,
I mean, some description would probably be nice.
What would be over 25 foot?
Oh, so that thing is the ladder.
Yeah, this is
Okay.
the ladder. Isn't that crazy?
All right. It's okay. It's not like I'm expecting a very graphic.
It's 7 feet off the ground, and
It actually is not 7. It is changing. So I get what you're saying. So the ladder is actually the only thing that has a constant number. because it's 25-foot ladder. And the ladder is essentially moving up and down this wall as it's falling. So we will focus on when it's exactly 7 feet off the ground like you drew, but we should probably not write the 7 in yet, because that's just gonna be part of the problem as we solve it. So because it is changing, we'll give it a variable,
Okay.
whichever letter you want.
A.
Sure.
It's going down by 3 feet per minute, right? So.
I don't know, that's what it says. You were looking at me for confirmation, but you just read the same thing I did, huh?
What else are we supposed to do? You said draw it.
True. I mean, you have most things kind of set up on there for right now. Okay, getting better. Is that triangle that you drew, is it a 90-degree angle? And how do we know it's actually 90-degree angle?
There's a wall and a floor.
I've seen some houses that are not.
They're not supposed to be.
Correct, but there is a word in the problem that actually, vertical. So when it's mentioning vertical, it doesn't say the ground is flat, but the vertical wall means it's straight up, so that's kind of where we should assume the 90-degree from. Okay, so the picture's actually perfect.
Great.
Oh, you guys wanted to be done teaching already?
Yes.
Jeez. You did not earn your money today.
Yep, correct. You don't get paid.
I mean, that, you do have a good point. You're not getting paid either way. So I guess you did earn it. It's hard not to earn the money if you don't get paid. Okay, I got 9 and 1 again. 10. Oh, jeez. I'll give you the question. If we need to pass it on, we can. Because it's tough when you're by yourself. Okay. This problem doesn't mention in any which way any kind of formula to use. The only thing it talks about is like lengths. Okay? So our picture is what? Triangle of some sorts. Is there a formula you know that deals with lengths of a triangle? Whoever's whispering it definitely whispered it, right? But oh, I don't know what you said. It's okay. It's okay if you're not sure. That's why I said I was going to give you the question. I figured I would give you the chance. Okay. I know I heard somebody whisper it, but like most of the formulas we're going to use are not going to be super obscure. They're going to be things you've done before. So what's the main formula we've dealt with for lengths of a triangle sides? Yeah, Pythagorean theorem. Even if you don't remember the name of it, it's a squared plus b squared equals c squared. Think you can write that one up there? Excellent. I mean, conveniently, they even labeled it A and B. But it doesn't matter what you label it. I bet some of you labeled it Y and X. And if you did, that's still correct. Oh, perfect. You even put in the 25 right away.
Oh.
No, that's excellent. So because the 25 is a length that doesn't change, you can enter that. It's not a variable. So if you wrote c squared, it is correct, but it's not variable and it doesn't change, so you can put information in place of it right away. The a and the b we can't because they are changing. So we've got a squared plus b squared equals 625. Good. How are we feeling about this so far? Now, we obviously don't have any labels. I should have done what we've done for the other questions and said, what are we finding first? But for this problem, I thought it might be easier for us to even like visualize what we're talking about before we figure that out. 7. 7. What are we trying to find?
The measure of the lengths of A and B when the distance between the top of the ladder and ground is 7 feet.
You gave me a whole bunch of answers there, I think. You said try to find A and B? Oh, no, not quite. We actually will know A and B already. It's asking us to find, so it says, what is the rate of change? So derivative. What is the rate of change of the distance between the bottom of the ladder and the wall? Which one of our things up there is between the bottom of the ladder and the wall? B. Bottom of the ladder. Yep. Top of the ladder and the wall. Yeah. So it's asking us to find
The derivative
of
distance between the bottom of the ladder and the wall.
which is called
B.
B. It's asking us to find the derivative of B. So it's what is dB dt? Now, I'm purposely going through these as slow as I can because I need you guys to be able to look at these problems and set everything up on your own. So I'm trying not to just fly through the steps. I'm trying to get you guys to figure out the steps we need to do. Now, we also have that. And pretty much a guaranteed step of all of these is going to be derivative. I mean, you have to know what equation to take the derivative of, and that can sometimes be part of it on its own. 2a dA dt plus 2b dB dt equals 0. Now, let's just say you didn't realize that you could put the 25 in right away. If you did c squared, this would say 2c dc dt. But since the ladder isn't changing length, dc dt would be 0. So even if you didn't put in the 25 right away, this would still turn to 0. Okay, good. Well, I mean, dB dt is what we're trying to find. So we got that, but there is clearly lots of other info. What the heck? We have to be able to fill in all of those. Anybody feel like they have parts of it sort of figured out?
dA dt is 3 or negative 3.
Okay, so it says the ladder is sliding down a vertical wall at a constant rate of 3 feet per second. And correct, if it is going down, A is getting smaller. So it is negative 3 feet per second. And that would be dA dt because it's A. Okay, good. That's usually the hard one to figure out right away. Okay, so I'll put in negative 3 feet per second.
Feet per minute.
Oh, is that what it said? Oh, what? Why would you measure feet per minute on a ladder? I just assumed seconds because feet per minute, that's so slow.
That ladder is
More than enough time.
So if that ladder's falling that slow, you're basically just like being terrorized to death. Or it's going down so slow that you really won't care if it falls.
probably
Would that make A, B, 7?
Oh, that's what I was getting at, yep. So it does actually mention when the top of the ladder is 7 feet from the ground. That's going to be the information that's like at an instance. So, correct. Now this is a constant change, this is an instance, and we can figure that out.
Do you have to do Pythagorean theorem to find B?
Yeah. So sometimes you're going to have to do some extra work to find other numbers you need to know. I think it's 24, right? Isn't that one of the Pythagorean triples? 7, 24, 25? Yeah. If you know the answer because of something like that, you can just write it. Otherwise, you do Pythagorean theorem to figure out 24. Okay, so 2 times 7 feet times negative 3 feet per minute. Plus okay, so I guess I would have to add, I was gonna say subtract, but that one's negative. What's 14 times 3, 30, 42? So we would have to add 42 feet squared per minute. To both sides. So we currently have 48, I'll just call that X or something. 48X feet squared per minute. I shouldn't have done the labeling, that's gonna make it weird to explain to you, I suppose. I actually wanna keep the feet per minute on that one for labeling purposes. Maybe I shouldn't have put that label on it to show you where the label will come from. So if I divide both sides by 48 feet, seven eighths. 7/8 feet squared per minute divided by feet would be feet per minute. The labeling should always actually work out, but sometimes you can kind of confuse yourself setting it up. I don't know. Probably the hardest part for you guys is just figuring out where to get the numbers from, is my guess. Does somebody want me to go over where some of those numbers come from?
Where'd you get the X?
X?
48X.
Oh, question mark? Oh, I wrote question mark instead of dVdt. So if you want to just leave dVdt there the whole time, you certainly can. It seemed like there was kind of an overload of info. Probably should have just left that to be, so you guys get used to it. What time we get done? 12? What? 27? We have too many schedules. I get. Should we do a third one, or do you guys want some time to work on this, or what? Third one? Okay.
Can you,
Leave it up there for a minute? No, go ahead. These aren't something that's, your brain is just gonna digest in an instant. I'm recording it too.
I just gonna think.
Sure. Do you want me to scroll down so you have the whole thing?
No,
Okay.
I'm fine.
Table 5. Guess what you guys get to help us with? Now, I will, oh God, what? My brain just doesn't want to do multiple things at the same time today. I will say from years of teaching experience on this problem, most students absolutely hate things that have directions and like numbers, and I know I think in pre-calc, didn't you guys do stuff with
Yes, we did.
air coordinates?
Yes.
This isn't that exactly, but for most people it feels the same. So at noon, oh, You've already got an A.
Yeah.
What is A?
Ship
Ship
A is
But-
heading, is 150 kilometers east of Ship B. Ship A is sailing west at 35 kilometers per hour.
Going that way.
Whoa,
West, yeah,
okay.
sorry. Ship
I
A
think
is
you lost
west.
everybody already. Oh, okay, well, arrows do help, all right. So at noon, ship A is 150 kilometers east, which means it's on the right. Ship A is sailing west, 35 kilometers per hour. Ship B is sailing north at 25 kilometers per hour, all right, all right. This is at noon,
Mhm.
but we don't want the answer at noon. We want to know how fast is the distance between the ships changing at 4? Oh dear.
So we'll figure out
We've got-
Pythagorean theorem again.
Now, here's the part that kills everybody in this problem is the noon and 4. Why are they trying to give us times maybe?
To get an exact value.
It's telling us how far they actually traveled without telling us.
Yeah. So
So it'll be a triangle.
100 kilometers.
What? You're writing down the Pythagorean theorem, but you don't even have a triangle drawn.
So,
You're not wrong though.
Wanted area to.
Yep, you're not wrong. Whoa,
these,
did we put 2 smart people up here for everybody?
And then this one, 35 kilometers per hour times.
someone have a calculator on?
They want you to slow your brain down.
Okay.
They do not know what you're doing. You guys are acting like college professors right now. Because this is what college professors do.
How fast?
They know everything and
we
they immediately
find-
do everything for
Gotta
you.
find distance first.
Okay, let's go on your picture. You just drew 100.
Yes. So
Where
we
the-
figured out how far they are.
Wait, don't tell me.
moving.
Don't tell me.
We are trying to figure out how far they have already moved. So figuring out.
Why? Where? On the left?
Yes.
Okay, so
Oh,
ship
okay.
B is moving 25 kilometers an hour north. So.
And it went for
4 hours. So over 4 hours, it moved 100
from
kilometers.
noon to 4 p.m.
Then from noon to 4 p.m., 35 times 4, that is
140.
140, yeah.
Okay, so.
So the
it's
only reason it
140
mentions
minus
noon and 4 p.m. is to tell you that the ships were going for 4 hours.
It's 150 minus 140.
It's
They're already-
telling you how to draw it. Right.
They're already 150.
It's telling you how to draw it in a terrible way.
How do you know when to do the times 4?
Because they went for 4 hours.
So
So
we
you're
need
like
to figure out how.
extending that same.
So the
figure
first
out-
picture,
not how
that was
far
drawn
they
was
are
at
from each
noon.
other, but how far
That's
they
where
are.
they
just
started.
across from each other at noon.
And then they're each traveling different directions, but they're doing it for 4 hours. Oh, where'd the 10 come from?
So we saw that it was 35 kilometers per
Wait,
hour.
wait,
and
you're telling
then
me again though, I already know.
We found out that there was 30. Yeah, you want to explain
Okay,
it?
so ship A is traveling.
You're doing a great job, though, Ben.
35 kilometers an hour, and it's 150 kilometers away from ship B. 35 kilometers an hour for 4 hours is 140 kilometers, right?
Yep.
Okay, so that means that it is
It's
10
close.
kilometers away from the original position of ship B, which is where that is. So ship B again has moved 100 kilometers north. Ship A is 10 kilometers away from ship B's original position.
And then to find our fun little C, does someone want to Pythagorean theorem this?
100.4987.
Okay.
Off the top of your head.
So we have 100.4987.
Square.
Actually, that isn't correct.
Oh no, we want the speed.
Yeah, what I was gonna say is, when you wrote a squared plus b squared equals, you have to write them as variables if they are changing, and the distance between the ships is changing. Yep, so we actually need the c.
So now we need to differentiate it because, of course, we're in calculus. Why wouldn't we?
Well, yeah,
All right.
We need to differentiate it because we need to find out the speed at which they are going away from each other.
So dc dt.
Mm-hmm.
We need to find derivative of c.
Then that would be 2a.
Let's move.
I think the most interesting thing to me
You
is,
wanna?
I'm confused.
I can see how your guys' brains are working and it's all over the place.
But it's working, it's working.
I just said how it's working, yeah. I didn't say your brains were broken. Don't worry, I'm gonna redraw it and put it up there. This one is probably a medium difficulty problem, and we're doing it on day 1-ish. So, I'm gonna redo it. I was just kinda curious to see how you guys would do it.
Okay. Now, with all these things, we actually know all the variables except for DC/DT. We know all the variables because 2A is our distance from A, so that's our 100 kilometers. DA/DT.
No, it's 10,
Oh yeah, what?
it's 10.
DA. So A is
10,
Alright.
then B is 100.
well, yeah. Then B is 100, right? Yeah.
It's okay, it would've worked, because you would've had,
Same answer.
Yeah.
And then since we have 10 for our A, that means our DA/DT is 35 kilometers per hour.
Yep.
Oh, okay, that's. Little help, please.
what do you wanna help with?
Well, the screen moved a little bit.
Oh yeah, it does to me all the time.
Okay.
Whatever.
Oh, figured it out. Nice. That means our DB/DT is 25 kilometers per hour.
So let's just fill that in real quick.
Yep. and
Okay,
then
I'm pretty proud of you, I'll stop you there because
C is our.
it's starting to get crowded and, clogged. You guys did excellent. However, it actually would've been slightly wrong.
That label's good.
We're up to
No, actually, I wasn't even talking about labels. Did anybody see the one minor detail that they wouldn't have had right? No, they meant that part right.
Isn't it supposed to be -2?
Good. The 35 kilometers per hour would actually be negative. Because the number is getting smaller. So your final answer wouldn't have been correct, but you had everything set up perfect. Okay, good. I'll start over because this is a tough problem to explain. I was actually just kind of curious how you guys would do as a class to sort of figure it out. That was honestly very good. This is day 1, so. That one's kind of my favorite one if you do the eraser around the whole thing. It makes you feel like you've got powers. I will start it the same way they did though, is we just should draw what it says. At noon, so the noon actually doesn't mean anything, it's just telling you ship A is 150 kilometers east of ship B. So in your head, you have to figure out east, right? East. So ship A is to the right of B. Okay, that's what it's saying. Did I just write that backwards? It is so hard to write and talk at the same time. You would think after teaching for a long time I'd have that skill down. Ship A is to the right of ship B. I said it correctly, I wrote it backwards. Ship A is sailing west at 35. Now, I don't know it's negative yet because I don't really have anything set up. Ship B is sailing north at 25. I would say for most students, being able to draw it is the most helpful part of the problem. Not being able to draw something is where it makes it feel the hardest. So we just have 2 ships, they're moving. How fast is the distance between the ships changing at 4 p.m.? Well, so it's trying to tell us the 4 p.m. is trying to tell us that it is 4 hours later. So we drew it at noon, but it wants to know 4 hours later, so they are not going to look like this 4 hours later. So clearly B is going to be up here somewhere. A is going to be over here somewhere, although it could actually be to the left of B. We don't know until we figure that out. 25 kilometers an hour. Well, that number is getting bigger, so this stays positive, and times 4 would be 100. So it is telling us that at a moment or at an instant is 100 kilometers away from where it started. If we're putting this on a grid and dictating it to like numerical, X, Y axis, that's when positives and negatives happen. But, so 35 kilometers an hour means that after 4 hours it went 140 kilometers. These were 150 kilometers to start with, so if it went 140 kilometers, it didn't quite make it to B's original position. That's where that 10 came from. Depending on this problem, if they would have said 6 hours later, ship A would have been over here. So it just kind of depends on the problem. So this is ship A's current position. And since this number got smaller, that definitely is a negative. It is asking us about the distance between the ships, which we didn't draw yet, but the distance between the ships is the hypotenuse. And if A would have been over here, it still would have been a hypotenuse. Okay, so once you figure out it's a triangle, then we can label them. The sides of your triangle do not have to match up with what you labeled the ships. You can call these whatever you want. In fact, I'm going to call that Y, I'll call this X, because then it helps me visualize horizontal, vertical, whatever. And that's a hypotenuse, so we call it H or C or whatever you want. Actually, I could call it D for distance between the ships. I mean, it doesn't tell us what to label things.
No, yeah, I get it.
It doesn't tell us what to label things, so you can do whatever you want. But it is a triangle. It's dealing with changing lengths. So Pythagorean theorem, just like the one above it. So we kind of take into account what the shape is and what's happening to the shape to figure out which formula to use. This one, all 3 sides of the triangle are changing. So you need to use all 3 letters. The ladder, this wasn't changing, so we could keep it as a number. I already broke my rule from yesterday, didn't I? Yesterday I was trying to be very vigilant on telling you to say you're taking the derivative. I guess I was focused more on the story problem and how to do it than that. I feel like you guys are pretty good at the derivative part of it now, or like currently. Does that feel accurate? Okay, so you don't need me to go over the derivative part of it? Okay. Otherwise, if you want me to go over the derivative, just say so. Okay, now that I drew a picture and I kind of put labels to the, oh my God, I wrote ABC, didn't
Oh, me too, it's fine.
I? I'm not rewriting that, that's for sure. I like how I decided what they were gonna be and then didn't use it. There, it was like that from the beginning. This will be dA dt, because it's how fast the vertical one is changing. This will be dB dt, because it's how fast the horizontal one is changing. And then the question originally stated, how fast is this changing? So that's what we're trying to find. There's going to be a ton of information on every one of these problems. Do your best to try to write it legibly. I know I was making fun of you guys thinking all over the place. That's pretty normal. Like, that's how everybody's brains works. Do your best to try to write everything organized as much as you can, because otherwise you'll get lost.
Does it matter which one, like,
like the vertical or the horizontal, like
Nope.
A or B?
Nope, not at all. I mean, especially for this formula, because they're just the two legs of a triangle. Okay, so then you just kind of put all this information in, which is a lot. I'm not even gonna get to finish, am I? A was 100. DADT was positive 25 kilometers an hour. B was 10. And then negative 35. I 100% ran out of space. Oh, that's nice. C. Ooh, what is C? What did you say it was? Like, what's some weird decimal? Like 104.
498.
It's 100.4.
Oh, gotcha. Took my brain a moment to realize that that's different than what you were saying. And then DCDT is what we're looking for. What did, I'm sure by now somebody else went through and finished that.
What? Oh, yeah.
And that would be kilometers per hour. No, it's how fast is it changing? So it has to have,
That's not, the final answer is like 21.3, right?
Well, because
The
you didn't
200
multiply by the
998
derivative.
is C,
you were telling me what that was.
yeah.
Oh, I was looking for the final answer, because we're out of time. 3 decimals.
3.
Yeah, we don't have any time for me to write it, so I at least wanted you to have the answer. These problems go super slow. There's no way around that. Especially once you start getting into shapes that are like more complex than a triangle or a circle. So, if you get time over the weekend, I would start working on some of the homework. You might run into some you can't finish, and that's fine. We'll keep working on these on Monday. Just, you'll be able to start every problem no matter what. Like, you'll be able to try to fill in info and do things like that. You might not be able to finish. So we've got some a little bit more difficult ones I'll do Monday. But nice job.